problem here that actually uses an alternate definition of absolute value. Now, if you did this directly, there would be like 4 cases to check. Now, the case I'm about to show you is a little tedious, but to me it's still interesting. Now, let's just take a look at this alternate definition. Like, we know that the absolute value of minus 9, we already know that that's equal to 9, right? Just from that fairly straightforward piecewise definition of absolute value. But notice we get the very same thing right here, equals to the square root of minus 9 quantity squared, right? Now that's a long way around, but at least you don't have to deal, with a piecewise definition, which isn't too much of a burden, but this is just another way of doing things. All right, and so anyway, we get that is certainly equal to the square root of 81, which is certainly 9. Now again, it's just another approach. You may think it's a little too much trouble, but anyway, so we have square root of 81 is equal to 9. Okay. Now that's exactly what we use on this next line. Okay, on this very next line, we just convert this to the absolute value definition. All right, and then the very next step is just to isolate one of the radicals like you would typically do. Now, I arbitrarily isolated this guy right here. You could have done the other one also, right? Now, this very next line, I'm not going to spend a lot of time on all the details, but all I did was really just use the result a squared minus 2ab. It's this piece right here. To AB plus b squared. Okay, that's all this part is right here. Okay, y'all, and as I said, I'm not going to go through every last detail. I showed most of the work right here. We'll just scroll on down here and just take a look at what transpired. Just quite a bit of work. We had to square again at one stage of the problem, but after we did all of that, we ended up with this expression right here. Okay, and again, hopefully I've left enough detail up here for it to make sense to you. It'd be tedious just to go through every last step. But we end up with this statement, and it doesn't look too comfortable right now because we have this 109 over 4 quantity squared. Okay, and there's a little bit of arithmetic here going on. The understood denominator is 16, so that's why I wrote the 16 times the 169 here. Okay, now again, we're dealing with equivalent equations to the original, and so let's keep on moving. Now we actually end up with something that's surprisingly straightforward to solve. It turns out that 207 is divisible by 69, so that's where this equation comes from. Okay, and notice also right here something that's very, very useful is that 133, you could use the quadratic formula right here, right now, if you wanted to, but 133 is equal to 7 times 19. That's its prime factorization. Okay, so equals to 7 times 19. So you see, you don't have to look too far for factors of 133. Now, a lot of you might be thinking, oh, you need an integer here. Well, you really don't. You can try to factor with rational numbers also. No law against that. Now, also, if you check the discriminant of this, you get a rational number, not an irrational number. Okay? So what that does, folks, that leads us to this next step here, which is kind of fun here. Okay. we know that it's going to admit a factorization. It has to look like this. I have to start with this at least. Okay. Now, we also know that the signs are going to have to alternate. It's going to have to be a plus-minus combination, right? It's going to have to be a plus-minus combination. And another thing that's quite useful here is that this 3 here means that the sum of the zeros is -3. In other words, the zeros that we get will have to sum to -3. It's called Vieta's formula. Okay, so let's keep going here. Now, what we can do here again is just take a look at combinations of numbers that will give you 133/16 and also sum up to -3. Okay, and so what we can do right here is, again, I'm leaving out some of the work here. It's trial and error. You could try the 116 combinations, the 28 combinations, but it turns out the 4/4 combinations work here. So this is going to be 7/4. Yeah, again, in the name of time, I'm just leaving out. There was a lot of trial and error here, but you could have just used the quadratic formula because you get a discriminant that works out nicely. That is, it's a rational number. But it turns out that 7/4 and 19/4 get the job done right here. Now notice their product is the 133/16, right? That's a 4, folks. So that's 19/4, 7/4, and so your two zeros are actually going to be your two solutions to the original equation. And I'll write that just solution set form here. Okay, it would be minus 19/4. Minus 19/4, and then what do we get? 7/4. And you can check, so that's the solution set. You can check, for example, let's try out 19/4 here, or minus 19/4. We can try minus 19/4. If you put minus 19/4 right over here, minus 1, that gives you minus 23/4. Okay. And again, folks, that's what happens when you put minus 19/4 right here. Now plus minus 19/4 plus 4 would be minus 19 plus 16. Okay, so that's going to be plus, right there again, folks, if you put minus 19/4 right there, that's minus 19/4 plus 16/4, which is going to be plus minus 3/4. And I'm just checking one of them out. You guys can check the other. It's pretty easy. It's not too hard to see it. Okay. So what we get right here is 23/4 plus 3/4 after you take absolute values is 26/4. And that certainly reduces to 13/2. I haven't mastered this screen yet, folks. I don't know what I'm doing wrong, but it moves on me. Okay, so 13/2, folks. and that checks right there. So you have your 13 over 2 going on right there. And y'all, again, I do want to point out to you that this 3 right here, these two zeros actually have a sum. They sum, and that's called Vieta's formulas. If you're familiar with that, this gives you a better way to, you know what I mean, to narrow down what your zeros are going to be. So these two numbers actually sum to -3. Okay, minus 19 over 4 plus 7 over 4 is minus 12 over 4, which is -3. And if you're familiar with Vietas, you alternate the signs because of the way things factor out. But anyway, y'all, I hope you enjoyed it. I thought this was super cool. Liked it a lot. Let me know what you thought. See you later.